Hello and welcome to my channel. In today's tutorial, let's talk about K6, a powerful open source load testing tool created by Grafana. K6 has a simple installation setup and allows us to write JavaScript code. It's compatible with Linux, macOS, Windows, and also with Docker containers. The first step in our tutorial is to install K6. You can easily do this by visiting k6.io and follow the installation instructions according to your operating system. Once installed, let's verify the installation by opening up a CLI terminal and typing k6 --version. Great, it seems like my k6 is 0.49. Great, now that k6 is installed, let's create our first performance test script, starting with a new folder. We will create a JavaScript file and use a simple examples to demonstrate how easy it is to create this kind of load tests. Regarding test scenarios, we are going to use an API playground provided by K6 as well to send a GET and a POST request. This is the REST playground provided by K6. Here we have a public get crocodiles and also a post request that implies user registration. Let's get it started by creating the JavaScript file into our folder. Great. The first step is importing HTTP sleep and check from K6. Next, we define our options as a constant, such as the number of virtual users and the duration of the test. Virtual users, let's say 3, and the duration, that will be 5 seconds. Next, create a default function where we will specify our HTTP request using the http.get function. Let's start with get all public crocodiles example. So this is our endpoint. And we should receive status code 200. http.get followed by the URL, let's refactor this code so it will be template literals base URL / public crocodiles /. Okay, so I will store this in a constant called response. The next step is to create an assertion for the response of each request that we are going to send to this URL. Hence, I'm going to use that check function. Check. The first argument is the response, and the second argument will be an object. Status code 200, arrow function, status equals 200. Great. Save the file, and that's it. Now let's run our test by opening up a CLI terminal. Simply type k6 run followed by the JavaScript file name. In our case it will be script.js. As you can see, we have some metrics in real time and the requests are being sent to the server, and our test passed. We have 0 errors, and all the checks have been achieved. And here we have lots of load metrics like the request duration. Here we have an average, a minimum, a maximum, and some other details. We have 0% failed requests and some other details. As you can see, the maximum number of requests that were sent to this get endpoint was 97 requests sent by 3 users. Simple yet intuitive, isn't it? Furthermore, we could get rid of this options constant and pass the number of virtual users and also the duration directly from the CLI command. Hence, I commented these lines of code, and I'm trying to rerun the previous command from the CLI, adding additional flags like k6 run -- virtual users space the number of users -- duration 1 second and script.js. This time the test execution will take only 1 second using 3 virtual users. And in this 1 second time interval, only 7 requests were sent to the server, and here we have the same metrics like average, minimum, maximum, and so on. Simple, isn't it? Let's continue with the second endpoint that will be a post request for user registration. This request will be a bit more complex, and I'm going to reuse the existing code that we wrote in the script.js, and for demo purpose I will create a new script called create user.js. Paste the existing code and slightly refactor it. The base URL is the same. The path is a bit different. Instead of public crocodiles, we will have user/register/, and I'm going to update it accordingly. The method instead of get will be post this time. I will remove the comment in order to have again the options constant with the number of virtual users and the duration. The status code for this post endpoint, I am pretty sure that it will be 201, hence we will need to update it accordingly. And one more thing about this post request, usually they imply a request body, hence let's check it out as well. We have some raw data, we have a header with the content type application JSON that we will need to pass as well. But meanwhile, I will copy this content and paste it in a JavaScript constant. Request body equals this. I will insert some data. Okay, and regarding that header information, I'm going to create a new params constant that will handle headers. And type content type application JSON. Okay, we have some constants and we need to insert them into our post request. So the first argument in the post function will be the URL followed by the request body followed by the params that contain our headers. Great, it looks good. It's worth mentioning that this particular endpoint that we are trying to test in our script has some constraints. So the constraint is that each post request needs to have a unique username and email, because you can't have multiple records in the database with the same URL and email. Hence, in our script, we need to find a workaround to generate unique value for each request that we are going to send in case 6. I'm going to Google for a solution. We have a first result that implies some random string value, which sounds good. I'm going to click on it, and here we have an example of something that might be useful for us. Firstly, we need to import this kind of code snippet. So we will have a random string that we can use, and in our default function we can create a new constant calling this random string and giving the length of the characters as an argument. So in our default function I'm creating a new random username value with the length of, let's say, 16 characters. This random username I am going to use in our request body, and I would also like to use in the email property, concatenating with the @gmail.com. Great, looks good. We have the options enabled, so let's simply run the test and see what happens. K6 run create users.js. Okay, the tests are being executed, requests are being made to the server. Here we have the metrics, and as you can see, some of the checks failed. Currently 0 checks passed and all of them failed. Let's make a quick debug on this scenario. Why is this happening? Base URL, request body, params, response. Okay, let's use a console.log to analyze this response. Run the script again, and we might get some insights. Okay, I'm going to parse this JSON response to increase the readability. However, I spot a status code 400, a bad request, so something is happening. JSON parser on Google. I'm going to click the first link and paste the cancel message. So we have status code 400, bad request. And why do we have a bad request? Oh yeah, because we need to parse this JSON. Okay, so in K6 the request body needs to be stringified, and I'm going to use JSON.stringify and gives this entire object as an argument to this function. So I'm going to cut and paste it as an argument. This should do the trick. Save the file and let's run the test again. Three virtual users, execution in progress. Let's see the results. Great. Our tests passed. We have all the checks passed. Three requests in total. request duration, average 5.5 seconds. Not good, not bad. And yeah, this is it. It's important that the number of failed requests is 0. Simple, isn't it? Thank you for watching. Please subscribe to the channel for more tutorials, and happy testing!